Very good. Welcome to the National Library and welcome to this SoundTracer workshop. My name is Gjems and I'm the head of the music section here at the National Library. And this workshop is co-organized by the National Library and Ritmo, Center of Interdisciplinary Studies of Rhythm, Time and Motion at the University of Oslo. I'm especially delighted to welcome keynote speaker, Professor Dr. Maynard Müller. Professor Müller holds a professorship for semantic audio processing at the International Audio Laboratories Erlangen, which is a joint institution of the Friedrich Alexander Universität Erlangen-Nürnberg and the Fraunhofer Institut für Integrierte Schaltung, IIS. I hope that was correct. His recent research interests includes music processing, music information retrieval, audio signal processing, and motion processing. We are especially looking forward to his presentation, Beethoven, Bach, and Billions of Bytes, when music meets computer science. So welcome, Professor Müller. I would also like to thank the local organizers, Associate Professor and Deputy Director at Ritmo, Alexander Refsum Jensenius, and Olivier Larilot, researcher at the Department of Musicology at the University of Oslo. The goal of the SoundTracer project is to develop tools for searching in large music libraries through movement, gesture, and other means. Today we are especially looking forward to see the last result of the development of a functional prototype of the mobile phone app that can be used to retrieve songs from actually public domain samples from the folk music collection here at the National Library. We hope that these possibilities in the near future will open up our song collections for new user groups and could further explore its content. The digital folk music collection at the National Library contains, at the moment, a large set of rather long recordings, each made of a succession of pieces of music that are disparate in terms of instrumentation. We are therefore especially happy for the SoundTracer project's development of new methods for automatically segmentation of folk songs into pieces and to classify them based on instrumentation. These can be convenient tools that we later can hope to apply in our daily archival work here at the library. I look forward to hearing all the presentations later on, and I look forward to further collaborations in the future on music information retrieval and archival research. And now, without further ado, here is Alexander Refsum Jensenius that will guide you through the rest of the workshop. Thank you.
Thank you, Rikard, for the introduction and for allowing us to hold this this workshop here, and also for collaborating with us on this project. So I'll give a quite quick run-through of SoundTracer and why we are here, and then I'll let Olivier do the rest of the talking about the project. But just briefly to mention that now we are affiliated with Ritmo. It's a new center for interdisciplinary studies in rhythm, time and motion at the University of Oslo. A collaboration between musicology, psychology and informatics. And it's we're setting this up now and will be really kicking off from August this year. And these are the senior people involved in the project, and we are currently also recruiting a lot of PhDs and postdocs to join us. And SoundTracer is kind of merging also into this in different ways now in the years to come. And for Ritmo, we are really trying to understand to have some big questions about human cognition and also about music in relation to this. This is kind of the visual abstract of what we're going to work on in the center. And as you will also see today, the SoundTracer project is really also about combining music and motion and in different ways, and you could also say audiovisual media. So it's really, the SoundTracer project is really getting into all the different parts that we'll work on in Ritmo. But back to SoundTracer then, and the story behind SoundTracer. And where it's coming from. You could say that this project is coming out of kind of 4 different types of disciplines that are kind of merged together. One is that of music cognition. That's how we kind of perceive music in different ways. And also coupled to music analysis in the sense of trying to understand what music is in different ways. Now, of course, connecting this with technology, you can say that music information retrieval is trying to kind of combine these things, extracting information about both how we perceive things, but also how things may be on paper in music, and use technology for doing this. And then finally, the last part here is that of new interfaces for musical expression, really, where we're trying also to explore how we can interact with music in different ways. And in many ways, you can say that this is kind of then being summed up, and I like to kind of make the difference between science and art and kind of say that they are two different things, but they can also be thought of as along a continuum in which it's possible to see that these are connected in different ways, and also that of nature versus culture, in a sense that's another continuum, where we're also trying to see how we can fit into both of these, and of course also then technology kind of encompassing all of this in different ways. Now, as many of you know, we have been working a lot with music-related body motion at University of Oslo for many years now, and we have been particularly doing this from kind of a perspective of motion capture in different ways, where we're looking at the body and how the body is moving when you're experiencing music. This is something I've been doing from looking at performers, for example in pianist studies like this one, looking at what a performer is doing while producing sounds, the sound producing actions, but also other types of motion in the body. We've been doing it on also more complex instruments more recently with, for example, with drumming. And we have also been doing the opposite, looking at how people perceive music and sound by asking people, for example, to perform air instruments, like, for example, performing air piano, and thereby trying to understand more about how people perceive music by looking at what they are doing. At the bottom of all of this is that we believe that there is a really strong connection between action and sound, where you can, if you hear a sound, you will also be able to imagine the actions and the objects that were involved in producing that sound, and the other way around, if you see an action, you will be able to kind of imagine some kind of sound quality. So it's really an interesting connection, cognitive connection, and also embodied cognition between action and sound. Now, to understand more about this, we started performing a set of sound tracing studies a while back. These are some pictures from 2005, I think, that Rafing and I and some others did in the basement of the Department of Musicology, drawing to sound. And here the task was that people would listen to a sound, and then they would draw on a digital tablet. And we would get different types of images like this that would kind of represent how people were thinking or experiencing the sound, which was interesting here. I mean, you had different types of strategies. Another one, you see that there are some kind of qualities that people pick up on, but exactly what are they? That's kind of what we were interested in studying. These studies were taken further by Christian, sitting here now, Christian Nymoen, who did a series of studies on different types of sound tracing, both with one hand and with two hands, and looking at also different types of sonic features, varying the loudness and pitch and the spectral centroid, and also combination of these, which is super interesting, but I don't have time to get into the findings here. But kind of exploring this idea further, we're looking at really at details in sounds and actions. More recently, Tejaswini Kelkar, also sitting here, has been doing also sound tracing of melodies, kind of extending beyond just looking at sound, but looking at melodic phrases, and trying to understand what's going on when people trace different types of melodies with a full body motion capture system. Now, then, Rafing and I and others have been talking about looking at how can kind of the embodied music cognition paradigm that we have been working within, how can that kind of be combined with music information retrieval. And we published a position paper, I guess, on this is kind of more a speculative thing that we did back in 2009 at ISMIR, where the idea was really to try to see how can we take the body into music information retrieval. And we gave a few examples of this. None of us were really able to take this research further and really to make this happen, what we kind of speculated about in this paper. But now, finally, we're kind of starting to get there where we wanted to be almost a decade ago. So the SoundTracer project is really kind of the culmination of a lot of ideas that we have been working on for a long time, and I'm really super excited that we got funding for carrying out this. So there's been a team kind of working on this in different ways. I should definitely highlight that most of the work here has been done by Olivier and also Benedicte as a research assistant, and Hans here from the National Library, and I guess with others we have been more supportive in different ways of this. Now, so what's going to happen today then is that we're going to listen to Olivier give an introduction to what he has been working on in the SoundTracer project for the last year. And then we'll also have a demo of the SoundTracer app and if you have an iPhone, you can download it yourself and try this one out. Then we'll have a short break, and then we'll have the keynote lecture by Professor Maynard Müller towards the end. So that's today's program. Then I think I just say thank you for coming, and I'd like to invite Olivier up for his presentation.